Hello everyone, and welcome to class. Today we are going to be working in Chapter 3. This is the first lesson of Chapter 3, 3.1, Graphing with Tables and Intercepts. Today we are going to accomplish three things. We are going to create a table for linear equations. We are going to find the x and y-intercepts of linear equations, and we are going to graph linear equations. These are our objectives. The first thing I want to start off with is what is a linear equation? A linear equation has the variables x and or y, so it can have both, it can have just one of them, but it needs at least one of them, and it needs to be equal to a number. The variables are also to the power of 1. That means there's no x squared, no x cubed. The variables are in separate terms. Let's look at some examples to get some better ideas of this. So here we have x equals 6. We have y equals 0. So these are variables equal to a number. Okay. We can also have 2x minus 4y equals 10. Or even y equals 3x minus 5. Okay. These are all good examples of linear equations. Some non-examples are y equals x squared. The variable here is squared to the power of 2. That's not good. That makes it a curve. And if you have x and y multiplied together, they're now together. They're not separate. And this causes problems. This means that it will bend and curve a lot on that one. Okay? That is stuff for later concepts. So, an important thing to note is that linear equations comes in all forms. As we can see from the previous slide, we have one right here, and we have one right here. Okay? They can look differently. They can be solved for a variable. They can just have x and y on the same side. It can be all mixed up. But when you have x and y on the same side, separated by a plus or a minus, this is what we call the standard form of a line. When you're in standard form, there's a couple special things to note. A, for example, must be a positive number or 0. If it is negative, you should multiply every term in the equation by negative 1. And C is what we call a constant. It is a number without a variable. So, notice that A has a variable, x, B has the variable y, C has nothing. It's just a number, a constant. Now with those definitions out of the way, hopefully you've written them down, we're going to go into some time of practice. We're going to be looking at the first example here. Determine if this equation is linear. If so, write it in standard form of a line. So looking at this, where's my mouse? There it is. So we're looking at this one. Does this make a line? Well, let's look at our qualifications. Are x and y separated? Yep, they're separated. They're not multiplied together. Is y to the power of 1? Yes. Is x to the power of 1? Yes. Then this is linear. Now, we need to transform this into standard form. The way to do this is we shall subtract 5/3 x from both sides, so that way we get the x on the same side as the y. We want our variables on the same side, just not put together. Now that we've done this, we want to make sure that we get the coefficient in front of x, this coefficient right here. It needs to be both positive and an integer. It cannot be a fraction. So to get rid of the fraction, we will multiply by 3. And to get rid of the negative, we need to multiply by a negative 3. So that's what we will do to both sides here. We have negative 3 multiplied to the left side of the equation, and negative 3 multiplied to the right side of the equation. Doing so will give us 5x minus 3y equals negative 21. And that's how we turn linear equations into standard form. Now, we're going to start working with a table, graphing using a table. So, tables are very helpful tools for charting patterns on linear equations. It allows us to see how much things grow by, because a linear equation grows by steps. It is useful, using a table is very, very useful when you already have one of your variables solved for. So looking at this example, y equals 2x minus 1. That is a perfect example for using a table, because we can choose our x values and find out what the matching y value is. So this is really, really nice for us. There are 4 steps when using a table. First, you'll choose your x values. So when you make your x and y table, you'll choose what x values you want. Then you need to replace x in the equation. You need to replace that x with the values you chose. So every time you write a different value in the table, you will need to work with the equation with the substituted value. You need to replace the value you picked for x here into here and find the y. You need to do it for this x that you pick, and you would need to do it for this x that you pick. So you would do it 3 separate times, solving for y. When you find all those y values, you write them in the chart. And it's that simple. Once you have your chart fully made, that's when we can start graphing. So let's see an example of this. So here's example 2. So with this equation, I'm making this chart. Now notice, my chart is different from the first one I showed you. The first one I showed you had x and y. I'm using a third level, a middle level, to write my equation so that way you can see the work I do on each of these x's to get my y values. You do not need to use this. This middle section is completely optional. But if it makes more sense to you, please use it. So, you're now probably wondering, why are my x values not counting in order? Why isn't it 1, 2, 3, 4? Because those go in order, those make sense, those are nicer. However, I want to caution you against counting by ones. You should only count by ones if the denominator of your x coefficient is 1. If we look at my coefficient in front of x, it's 3. Therefore, I am counting by 3's. So know that it is always best to count by your denominator. Now that we've established that, I'm going to take negative 3 and put it into my equation and work it out. So negative 3 times negative 2/3, that is positive 2 minus 1 gives me 1. That would become my y value. And I'm going to do this for each of my values. I'm going to plug in 0. 0 times negative 2/3 is 0. Minus 1 makes negative 1. I'll do this again and again. And now I have a filled out table. I know that my x value matches with this y value. This x value matches with this y value, and so on and so forth. Now we can graph. Now this is easy. So first I'm going to set up my coordinate plane. So I'm going to count by by ones, and I'm going to go up and down, left and right by 5s, or up to 5. Although I go up to 6 on my x-axis, because if we look at my x values, I go up to 6. And then I'm going to start plotting these points. So I have negative 3 on the x-axis, 1 on the y. That's the first point. Then I have 0 on the x-axis, negative 1 on the y. That's this point. I have 3 on the x-axis, negative 3 on the y. That's this point. And 6, negative 5. Now that I've charted my points, I'm going to connect them all with a line, and this shows that I have a linear equation because the line that I make through here is completely straight. It doesn't bend at all. So that is our first example with graphing. Now, I want to remind you that using a table is really nice when one of your variables is solved for. So the big question is, what if we have something in standard form? Something that isn't solved for, x and y both on the same side? I have an answer for that. You should graph using the intercepts. So, when you are graphing, I'll tell you this right now, you only need 2 points to graph a line. The only reason you would ever graph more is to see the pattern better, to find a specific point, or just because, you know, it helps you make a better line. It makes it straighter, okay, to make sure that you are actually graphing a line. The next thing to note is that every linear equation has an x-intercept and a y-intercept. So if we find our x and y-intercept, that is 2 points right there, and if you use those 2 points to graph it, you've got it down. You're done. Sometimes the x-intercept and y-intercept is the origin, 0, 0, for both of them. And on that case, you're going to have to find another point, a second point, since you're using the same point twice. But for pretty much every equation out there, you can definitely use the x and y intercepts because they will 99% of the time be different. Now, and so let's take the time to look at this equation in standard form and graph it. So here's our first example, 3x minus 5y equals 15. Now the first thing is to create our chart, to create our table, and we need to fill in an x and a y value. These values are going to be 0 for both of them. We want to get something that is on the x-axis and the y-axis. So to do that, here's my mouse. We want, if it's going to be on the x-axis, we need y to be 0. And if we want something on the y-axis, we need x to be 0. So that's why we know these two values. And please note that they are on different points. They are not on the same point. This x-intercept, or this y-intercept right here, right, x is 0, so we will get a y value. This will be on the y-axis. We don't want it to say 0, 0. That doesn't make any sense. We don't know that they match that way. But we do know that when x is 0, we can find what y is. And when y is 0, we can find out what x is. So let's work with that. Let's plug in these values and solve them one at a time. So we'll look at this one. And if we do 3 times 0, 3 times an x of 0, we'll get 0. So then we will take negative 5y equals 15, divide by negative 5, and we should get negative 3. The same thing works with the y value. If we plug in our y value of 0 and solve for x, we will get x equals 5. Now we just fill them in on the chart. This is perfect. This is absolutely wonderful. We now have our points. We have 0, negative 3, and 5, 0. It's time to graph. So let's plot these points and connect them, and then we are done. So, start with your graph again. In this case, I would recommend counting by ones, up and down, and side to side, and I would go up to 5, since our biggest x value here is 5. Now, I'm going to plot my points. So we have 0, 5, or we have 5, 0, and 0, negative 3 as our points, according to our chart. And now we just connect the line, and we are done. That's it. You have learned the lesson. So at this point, if you need to rewatch anything you want on the video, okay, I will also make sure that this is up on YouTube in case you want to rewatch it, okay, because I know it's easier to access it at my channel. Just type in Trevor Tinker, and I'm the one with glasses that look like this. Right, these glasses. I'm all like, okay. So you can go there and rewatch this if you need to. In class, we are going to answer any questions that you have and do a bunch of practice problems. So take this time to rewatch the video, write down any questions that you want, and that's the end of that. See you tomorrow.
It makes me so ambitious. My answers are judicious. Calculator never glitches. It's my mission. I get the answer right, and I'll be staying up all night just to check what I write. Mathematicians.